Hello, g'day, and welcome, or welcome back to Whether or Not, Episode 17. StellaQ here, and since the post-2020 circus came to town, every town, in lockstep, a lot of light has consequently been focused into the nitty-gritty, grimy corners of all the things, enticing more and more wee people to see through the multiplex of charlatan charades. We have been forced to endure the putrid extremes of insanely inverted social constructs like men who chest feed, drag queen story time, rainbow-flavoured imbeciles who politico-sterilise themselves, highly over-evaluating their deluded revenge. Alongside all this imbalanced nonsense lies the equally insane geoengineering gibberish, entrenched within the fictional climate emergency which has managed to take root in the fluoridated minds of those hypnotised masses that still remain spellbound. All by persistent design, of course. These pseudo-environmental scientists, and I do stress mental, perpetually spew forth their fairy tales of foolishness like kindergarteners hyped on red cordial, asking for the keys to some cosmic V8, the one with no brakes. Yet they still can't even reach the pedals. Blinded by their god complex, they dream up ludicrous plans for the next century or two, choosing to conveniently ignore that an accurate weather forecast beyond anything more than a few days is still far beyond their feeble reach. Even with all their fancy-schmancy simulations and quantizations wrapped in subsidies and money that is still wet from the print run. Professional predictors have been replaced by fervent fearmongers on short leads while we were all too busy looking down or chasing squirrels. Now, the chaos of the universe, it'll settle down once we give it a few tweaks. So pass the fine-tuning mallet and shut up and trust the science, okay? Because what could possibly go wrong, right? It's not rocket science to realise that billionaires playing with their expensive toys are some of the worst offenders to said climate emergency. And then there's the military. I mean, it wasn't enough to detonate nuclear bombs in the stratosphere, repeatedly, just to see what would happen. But that was 60 years ago. Memories fade, but the scars still linger. Aptly penned by band Tears for Fears. The hypocrisy of the whole climate change narrative is stone-faced slapstick, with its incessant indoctrinations, its averaging of historical data for convincing testimony, and its fundling of sickening profits for the self-appointed few who will never abide by the rules they lay down for us. They'll persist with their atmospheric debauchery, and they'll hold all of us account for the damage done, as they dish out increasingly draconian penalties and restrictions. These criminally insane harpies from hell claim to be saving the planet from the impending doom of progress, while at the same time they rape and pillage the very air we breathe and kill the environment in order to save it. None of this makes a lot of sense. But is that the point? To keep us all busy clutching pearls and holding hopeful hearings and celebrating the little wins that they throw us like bones as the real problems fly under the radar. I can't help but wonder, is the best way forward to perhaps slam on the brakes and throw her into reverse for a time? At least pull over. Weigh up the irreversible consequences of such madness. I mean, the kids are already furious with the boomers. Must we rinse and repeat with similar idiocy? Have we considered all the options, like making a few small changes on a large scale? A little less consumerism, perhaps? That would make a big difference. Regardless, the questions will never deplete, and nor should they. Let's take a deeper look. Let's get skywise.
Hello, Stella.
Today, I believe we're going to do a tutorial type thing regarding SAI. Tell us what SAI stands for.
SAI, Stratospheric Aerosol Injection, purposefully putting nasty stuff that reflects sunlight into the stratosphere.
This is the blocking out the sun business, yeah?
Yes.
Okay, sounds very intelligent.
Acronyms do.
Yeah. Okay, so where are we going to start with this?
Okay, so right off the start, I got a screen that shows the layers of the atmosphere. Okay. You're seeing that, right?
We are now, yes.
Okay, so where people live and where most airplanes fly, and jets included, that's the troposphere. That's where your clouds are.
Can we zoom in on that, please?
There we go. So that goes up to about 10, 11 miles. It varies from the equator to the poles. It's thinner at the poles, wider at the equator. The atmosphere is thicker at the equator where it's warmer. So the troposphere is, as a general rule, you have decreasing temperatures down to as low as minus 60 or so.
And that's the temperatures along the bottom?
Minus 60, yeah, Celsius. Let me scroll that up a little bit. Degrees
Celsius, okay,
C.
thank you.
So after that, you have the ozone comes in and you get warming, and that's through the next layer called the stratosphere. Some aircraft fly in the stratosphere, and the business jets routinely fly right at 45,000 feet, which is about 13 kilometers, 14 kilometers. And that's above what they call the tropopause, which is the dividing line between the two. So you have decreasing temperatures and then isothermal, which is unchanging or warming to the top of the stratosphere until you hit the stratopause. And then you got the mesosphere above that. And that's the coldest part of the world. But we're not there today. We're in the stratosphere we're talking about.
Okay. So that's above where at the troposphere is where our weather kind of happens generally, isn't it? That we see, like the clouds, and the stratosphere is above that. Okay.
And typically, even thunderstorms, unless they're really strong ones, this indicates a thunderstorm in the lower right corner, a cumulonimbus cloud. They go up, and then they hit the tropopause, and the tropopause is the starting of a stable layer because you have warmer air above colder. That makes the clouds flatten out, so you'll get those anvil tops.
Yeah, okay.
That you see a long ways away. They're very apparent. Nobody can miss them. That's called a cumulonimbus cloud. And most stuff does not penetrate the tropopause until you have something like a big volcanic eruption like Hunga Tonga. That went into the mesosphere. It crashed through the entire stratosphere, which is really stable. It had so much energy that it got moisture up into the mesosphere.
Wow.
So it's typical because of that stability of the stratosphere that when you get it there, when you get something up there, it tends to stay. It just goes around the world time and time and time again for a year or two. It does not settle out like it does in the troposphere, where you have rain happening, where you have thunderstorms like that. They'll come through, or a cold front, and it's a deep layer of moisture. It washes the junk out of the air quickly. Whereas, like if you have high pressure for 4 weeks, like we had in California with no rain, the air gets dirty because there's an inversion, which is the same thing as the stratosphere. It's warming temperatures as you go higher. An inversion caps the moisture. Like if you were driving off the coast of on the coast of San Francisco, you see the flat clouds as you're flying into that place because it has that inversion of temperature. It makes it stable. The same thing as in the stratosphere. Once you put something up there, it's going to go around and around and around. And let me go to another chart real quick. This is called Ventusky. I want to go to wind speed at a height at a pressure level called 300 millibars, which is about 30,000 feet. That's the lowest your jet aircraft will fly. So like right here you see these red bands. I'm scrolling in to find the jet stream, the polar jet stream. 97 miles per hour. It's a band of moisture or winds that are really strong and kind of like a river of moving air. 221 miles per hour right there off of Korea. So once it gets up into the stratosphere, though, this is still troposphere, 300 millibars. You have to. They don't give you charts for the troposphere until you get to this 10 Pascal one. 200 is still probably in the troposphere, but that's up in the stratosphere, and those winds are 140, 150, 200 miles per hour. You get something up there, it's just going to go around and around and around the world in those belts of winds, if they're in those belts of winds.
Right. So can I just ask, when the sulfur, etc., is sprayed in the stratosphere, you're saying that it hangs around there and it doesn't fall down. Is that because it sort of can't break through the tropopause?
It's because it's a stable layer where there's not much up and down motion. Gravity doesn't have the sway it has as down below. And also because gravity's still there, but you're farther away, number one, and also you're not in the rain. That's the bigger thing. You're not in the areas where the rain can wash the stuff out of the air.
Nothing to actually bring it down, right?
Combination of stability, where you don't have downward motions, and those combined. The point is, if you get the stuff up there, it stays up there for a long time.
Yep. It's just swirling around, floating, and being sulfur.
Right. And it reflects sunlight. So that's why they want to use it. And Jim Lee talked about it, and he's got all these papers, right? Jim Lee at Climate Viewer. And there's a guy by the name of David Keith. You want to talk about that a little bit, Stella?
Well, as far as I know, David Keith seems to think that he can sort of control all this sort of stuff with just a handful of planes, like less than 20 planes or something, from memory.
Yes. Yeah, like business jets. But they ideally want to develop a brand new plane capable of really high altitude flight, because right now, I think that one called the Sabre gets to about 60,000 feet, which would be mid-stratosphere. Not even that. What's 20? This is scale on this thing is kilometers on the right. No, miles on the right. Kilometers on the left.
Kilometers. Okay. Yep.
So what's 60,000 feet? About 15, under 20 kilometers. So they're still, the highest plane doesn't get very far into the stratosphere. The weather balloons pop at about 30 to 35 kilometers up in this area where the stratosphere word is. So they get to 100,000 feet. The highest flying plane might be a U-2, but they're not going to use a U-2 for putting sulfur in the atmosphere. You don't have a good way to get it up there, but business jets fly there all the time, right at 45,000 feet, which is low stratosphere, 10% of the way up.
Right. Okay. Yeah. So there's a purpose-built plane that has apparently not been built yet. So they're not actually doing it yet. Is that correct?
Correct.
As far as we know.
It's on the wish list, and yes, as far as we know.
Yeah.
So today, what we're going to look at here is, can you find situations where a lot of planes are in the troposphere or in the stratosphere? And so if you go to ADSB Exchange and go to the filters, you can set the flight levels. You can set a high and a low if you want, or right now I'm going to set it for 40,000 feet. And that's going to get you in the wintertime above the troposphere or tropopause into the stratosphere most places. And we're going to show you how to do that shortly. But just for the fun of it, these are the aircraft that are above 40,000 feet. So there's a count of 240 over the United States and Canada and Mexico right now that are up that high. That's a lot of aircraft. So now I want to show you how to see how high the stratosphere is chart right here that is made with radiosonde data that shows the heights of 250 millibar level in the atmosphere.
Okay, just before we go on, let's just recap. Radiosonde is the weather balloons, the data that comes back from the weather balloons, yeah?
Yes, every 12 hours, 0Z, 12Z, you have the radiosondes going up. Right now, they're actually going up right this very second. The world's sending about 800 of them up right now.
Okay.
This is a chart that is made from the 12-hour data from the radiosondes, and it gives a plot that shows the temperature. Like if you look at, expand this up a little bit and just pick a spot right here that's over Montana. It's showing the temperature of the air, 46 degrees below. It's showing that it's a 20-degree dew point depression between the temperature and the dew point, and it's showing the height of that level, which is 19,950. They just chop off the zero. So this is a long ways up in the air, like 40,000 feet.
Okay.
And what I'm looking for here is finding the spot that has the biggest dip, and that would be like over Oregon, because that's the thinnest part of the atmosphere along those dips in the atmosphere. So I want to go to another chart right now.
Before you do, can you just explain what all those lines actually mean?
Oh,
please?
those
blue lines?
Oh,
Yes.
the blue lines. Okay. Those are showing the wind direction. They're coming from the northwest. The arrow is showing them going towards the right.
Okay.
And that's your typical wind flow, is from westish to eastish.
Okay, so the blue lines are the wind flow. What are the black lines?
Black lines are showing the height of the atmosphere at that. It's connecting the lines. It's called the iso height. It's connecting the lines of equal height.
Okay, we're probably getting too much into the weeds here.
Yeah, we are. And so I'm looking for a spot that shows the thinnest part of the atmosphere. I'm going to say that's over Oregon or Washington. So I'm going to go to a different chart, and I'm going to pick one of these radiosonde stations, and I'm going to click on it and look over this place called UIL, which is showing the Tropopause at 7,852 meters, which times 3.3 is 25,000 feet, thereabouts. I'm going to look at another place, Salem, Oregon, and it's 6570. And then it starts warming and you're in the stratosphere. 6570 is about 22,000 feet. Mm-hmm. Probably not going to find much lower than that. So I'm looking for the thinnest part of the atmosphere where every aircraft that's above that point is in the stratosphere. 7813. So constantly changing. The atmosphere is fluid, so it's up and down and moving at all times.
Yeah, okay.
But this was 12Z this morning, which is 12 hours ago. And that current balloon that's up there right now is going to tell you that what the new chart in another hour when it comes out, it's going to have all the new numbers. Mm-hmm. But let's just go with 23,000 feet. So I want to go back to ADSB Exchange, and I want to zoom in on that part of the world, and I'm going to change that to 23,000 feet. Right here, I'm going to zoom in to right where that was, to where you're not elsewhere, and change that filter to 23,000. There were none at 40,000 there. There we go. 168 aircraft above 23,000 feet. Those are all, probably not all these to the right, because the heights were not, that trough was along the coast. So if I move that to the right a little bit, like that, it only does a count of what's showing. Still, over 100 aircraft are in the stratosphere right now. And these are passenger aircraft. None of these are military.
Okay, so this is how, tell us exactly what we're doing right now. What are we doing?
We're showing that these aircraft
in relation to SAI.
Well, they are inadvertently doing SAI because sulfur is in the fuel of every aircraft.
Okay, thank you. You pinned that. Right. So potentially every single plane that takes off and is above a certain level is doing SAI.
Correct.
Unintentionally.
Correct.
All
But a
right.
more typical number, let's say if you were to say the average, if I looked back at the Radisson data again and said 30,000 feet, and if I expanded that out without going into the individual stations and looking at each of those, I'm going to say 30,000 is your average tropopause right now.
Yeah, it's scary when you look at that. It's ridiculous.
So let's just say that down south, I know that 30,000 is not the case. Let me just chop off to there, to where only the northern half of the United States and Canada is there. That's very likely, without going into and looking at every one of those like I did with the Radisson, to look where that tropopause is. There's still 1,000 aircraft in the stratosphere right now, if I make that assumption that the stratosphere is at 30,000 feet.
Okay. Today. This is like right now. We're
Right
sort
this
of looking
second.
at it live at this time of recording.
Correct.
Mm-hmm. That's a lot of planes. I mean, it's just amazing that we can even see the sky at all, really, when you look at this. Blows my mind.
If you take that filter off and expand out, this is no restriction to the flight levels. There's 6,369 aircraft right now in this picture, but 10,000 worldwide.
Mm-hmm.
And a certain percent are in the stratosphere inadvertently because winter air is cold, and that means that the tropopause is lower in the wintertime.
Right, because this is being recorded in February of 2025. Winter over there.
Yeah, northern hemisphere. Whereas down south right now, where it's summer, your tropopause is much higher. And just for the fun of it, let me go to Key West, Florida. The tropopause is going to be a lot higher. 14,719 meters. Fort Worth, 13,000. So down there, you're at 40,000 feet for a tropopause. And you can look at it on this chart any day of the year. Here's International Falls, Canada border, 7923. Say 8,000 times 3.3 is say 25,000 feet.
Mm-hmm.
So a large percentage of the aircraft, the farther north you go, the tropopause gets lower. Here's up in Canada, 8,000 meters again. Where's another place like Caribou, Maine, 77. So say along the border of US and Canada right now, 8,000 is your number. Every aircraft above 25,000 feet is in the stratosphere right now. Inadvertently, because of the sulfur in the fuel, is polluting the world. And that stuff is going to stay up there for a year or two, just circling the planet at these speeds. At this location, those are 50 knot pennants. So everything that's right at 300 millibars is in the stratosphere, and it's going to the east at 60 knots.
Yeah. So why wouldn't they just sort of continue traveling around up there forever, or do they sort of eventually degrade, or what would make them go away? The bits of sulfur and stuff.
I'm sure they do degrade, and gravity does eventually pull them down. But again, it's just a real stable region where you don't have upward vertical motion there's a caveat to that. Jim's talking about what David Keith called, he's a very famous geoengineer, photo levitation. So if you have a black particle up there of carbon and the sun hits it during the nighttime, that particle is going to heat. Yeah. And if it heats, it's going to rise. So you can have motion, and you do have motion. He's talking about studies that showed huge amounts of particles of carbon at 18 kilometers. That's above where all the aircraft fly. So there is some motion if the stratosphere is not a really strong inversion that day. does move upward during sunlight hours because of that heating effect of those black particles of carbon that are in the exhaust of aircraft. So,
and as usual, the sun is what's driving pretty much everything. So that's going to be the determining factor.
Nighttime, you don't have the heat, so you're not going to have as much photolevitation during the night, and it's going to settle a little bit and move fast with the wind speeds, which again, right here, let's say 200 millibars. We're in the stratosphere for most northern places. They're moving to the east at 130 knots if you're over Wisconsin, and heading out into the Atlantic, and they'll be here at the edge of the chart tomorrow morning, and they'll be across into Europe in 2 days. And
there's nothing that's going to sit still, is it? Yeah, exactly.
No, it's going to move around the world in a week.
Yeah, which makes it very, very hard to prove as well. Like when it comes to, all these hearings and bans and things like that, it's like, well, okay, but as we've talked about before, things move around all the time, and it's going to be very hard to say, well, this happened over here because of what happened over there, sort of thing. Like it's almost impossible to pin who's doing what where by the time there's an effect happening. But so I don't know how that's going to get handled. But anyway,
there's your world winds right there. Your current world winds Saturday at the current time is about afternoon time. Then you could pick your spot where you want to see the winds. 100 miles per hour, 200 miles per hour.
Yeah.
Over Japan.
It's a pretty forceful wind, isn't it? It's going to move things around a lot, to state the obvious.
That's a strong hurricane up there.
Yeah. I think that's something that people kind of don't really, just don't think about. I never did. Of exactly how much action is going on up there. There's nothing stable or staying the same. If climate going to change, naturally.
And if David Keith gets his wish and gets specialty aircraft to put, what was the number? 200 million tons, if I'm not mistaken. Does that ring a bell to you?
I don't know. It's just, I just hear a lot. It's a lot.
We already have global cooling coming. It's already cooling.
Yeah. Well, I was reading the other day that we're actually in an ice age. I don't know how true that is, but on a really long time scale.
Yep. Global warming is no longer such a thing that they're trying to tell us it is. That is the point.
That's why they call it climate change now.
Yeah, they changed the words, yes.
Yeah.
And there's a lot of reasons for that. It has to do with El Nino, La Nina. It has to do with the solar cycles. We're in solar cycle 25, and that one's peaking right now, and now we're starting to go back down.
Yeah.
So there's that grand solar minimum thing, and then you got the Hunga Tonga moisture that was up there since the explosion in 2022, January. All that extra moisture that it put into the atmosphere, all those things really affect it. So,
do you think the Hunga Tonga moisture is still, I suppose it's still sort of creating an effect, let's say?
Certainly. 30 kilometers is where the balloons are popping. Right at that 30-kilometer line, okay. 35, as high as 35, halfway up.
Miles. Yep.
Halfway up through the stratosphere. That's a band of moisture that's as high as we're measuring. So we don't know that there's likely more up there and going into the mesosphere. And I saw a paper the other day that said that as well. But there's something up there, water vapor, intercepting sunlight and absorbing some of that heat.
Okay, so can we do a little bit of a wrap up? Can we just sort of put it into like bullet form, exactly what we've done here and why we were doing it and what we've shown?
Okay. So we're looking at right there, the layers of the atmosphere. The troposphere is where we live and where the weather is. Some aircraft get up in the stratosphere. The stratosphere is a very stable layer where if something gets up there by jet exhaust or whatever, it stays up there for a long time and just circles the Earth for, they say, 1 to 2 years. Depends on how high it is. And they want to make purpose-built aircraft to purposely put sulfur into the stratosphere to reflect sunlight to cool the Earth because they think the globe is warming. And
is that albedo?
That's albedo, yeah. I mean, it's
albedo effect.
Purposeful reflection of sunlight, intercepting it from hitting the Earth. Yes.
Yep. Crazy talk.
Very
crazy.
There's already in the wintertime that we showed you right there, the wintertime, the stratosphere is much lower. The tropopause and the troposphere are thinner when the weather's cold. And there's a lot of aircraft up there that are already in the stratosphere to the extent where that material is accumulating in the stratosphere right now by hundreds of aircraft around the world.
And so every day, every minute of every day, pretty much.
Of those 10,000 aircraft are up there, there might be half today that are above the tropopause in the stratosphere. And then the colder, when you had that cold snap going down to Florida, the tropopause was 25,000 feet in Florida. So all those aircraft in the United States were in the stratosphere.
Right, yes. Yeah. So there's a lot of stuff up there. Yeah, and I guess the moisture as well from like the Hungatongas of the world probably play a part in keeping things up there as well. Would they? Would it?
Certainly.
It's just a speculation.
I mean, I don't think the moisture would have anything to do with it's going to bring stuff out, if anything. The higher the moisture, the more it's going to come out with the precipitation that goes along with it. So, and you don't have much stratospheric moisture because of that stable place. It's called the tropopause. So the thunderstorms occasionally break through a little bit, a couple thousand feet, but typically the moisture needs an extreme weird event like a undersea volcano to get moisture deep into the stratosphere.
Yep. And, I mean, I, tend to think, are you finished with the chart now?
Yes.
Okay. I'm going to take your screen off, put us back. I tend to think too that, the Earth sort of knows what it's doing. Like, these things are possibly pressure gauges that, the Earth's kind of nature knows how to balance itself out because it's always recovering, isn't it? It's recovering from whether it's, a natural event or from something that we've done. It seems, I don't think the Earth is given enough credit, personally, on nature, including in our bodies as well. There's an incredible recovery that seems to happen naturally, and these people that think that they need to manage nature are, well, psychopathic, basically. Really?
I would definitely agree with that. The human hangover caused by the humans, it takes a lot of work by nature to clean that.
Yeah, it does. I mean, we're not doing it any favors, but I think nature's way more powerful than anything we could possibly do. It's just, I mean, it's really become apparent to me after doing all this, how big the Earth actually is. And I've said it before, but it still blows my mind. It's huge. And when you see these, the cloud seeding and that, of course, they're making a bit of a difference here and there. Otherwise, they wouldn't have done it for 30 years in California, for instance. But it just, I don't know, when you zoom out, it just seems like a little tiny, it's like a needle in a haystack sort of situation. Like I just can't see us really making that much of a difference, but especially in a positive way by doing all these things. But yeah, but the potential for disaster is unlimited, really. So stop it.
Concur.
Yeah. All right. Well, thank you for that. And hopefully that's brought a few more details into people's vision of what's happening up there and a little bit of understanding of how things move around a lot. Nothing is really stable. It's not going to be the same from one day to the next. So planning these things is, well, it's a thing in itself, isn't it? Trying to even plan these geoengineering ideas, let alone actually execute them. But anyway, there's a lot of money and subsidies being bandied around in the meantime, which I think is probably most of the point. Lots of greasy palms and misdirected money. That's where I think a lot of it's coming from.
Sounds like you're right on right there.
Yeah. Okay, well, thank you for showing us that, and we shall sign off saying, stop it. Leave the planet alone. Well, there's other things we need to do before we start doing that. I mean, that's just stupid. It's like putting a great big Band-Aid over the problems, like, why don't we work on cleaner things and better filters? And this carbon dioxide capture thing's ridiculous. It's just so insane. I just still can't get past the insanity of it all. It's like a bunch of children playing with toys. I don't know. Crazy. Anyway, enough of that. Thank you.
Okay. Thank you, Stella.
That's SAI wrapped up for today. Thank you for listening. If anyone is wanting to know a lot more with many, many receipts and lots of research papers and things like that, please visit Jim Lee's site. That is climateviewer.com. And he's the guy. He's the go-to guy with all the really boring data, which is really important. But he doesn't bring it in a boring way. He actually makes it quite interesting. Kudos to those who actually do. All right. Thanks for being here. Take it easy. Till next time.